Good. So now let's look at the exponential logistic growth model. Okay, back to 4.5. Any questions about the exponential growth? Okay. So what are we interested in? Oh yeah. Okay, 43 through 46. I think you're going to, maybe not, you're too young to think in these terms, but at some point in time you may. The logistic growth function, P of x, equals 90 divided by 1 plus 271 e to negative 0.122x. Models the percentage. Take notes. Always take notes when you read the problem. Percentage of Americans who are X years old. X is the age. With some coronary heart disease. Use the function to solve exercises 43 through 46. Here's the first question. What percentage of 20-year-olds have some coronary heart disease? What percentage of 20-year-olds have some? What am I asked to do? Of course. So P of 20 in a moment. Part B, 44. What percentage of 80-year-olds have some coronary heart disease? Very good. So let's plug in the function. Careful how we plug it in. So let's go to y equals. Clear if you have a function. Second and table said I have to reset that all the time. Okay, so go to y equals. The top is only one number. It's okay if you do not put it in parentheses for now, because it's one number. But the denominator needs parentheses. 1 plus 271 e. And in parentheses, please, negative, starting with a negative sign, negative 0.122x, 0.122x. Close the parenthesis for the power, come down and close the parenthesis for the denominator. And now go to second and table and plug in 20, enter, and plug in 80. So at your age of 20, according to the model, how many at that age have some coronary heart disease problem or situation? About roughly 3.66%. What about 80? How many of the 80-year-olds? 80%. 88.6%. Very good.
You said this formula will be given to us on the 20th.
Yes, of course. Of course. No, but there is no, very good question. There is not one specific logistic model. Every situation has a logistic model. So we will never be able to.
So it's specific to what it is.
Exactly. So this constant and this constant and this growth rate or decay is specific to the situation that it models.
So the important thing in a situation like this is just remembering to replace whatever
Yes.
for X.
Just read the question carefully and you just replace it. Yes. Okay, the other two. At what age? Is the percentage of some coronary heart disease 50%, and the last question 70%? Say it again. Yes. This is 43, 44, 45, 46. So 50% and part D 70%. What am I asked now? Now I'm asked the age. Yes, ma'am? Exactly, awesome. So 50 equals 90 divided by 1 plus 271 e to negative 0.122x. This is an extensive equation. It's not an easy one. Okay? So let's do this slowly together. The first hint that I will give you is this, which should be clear. Although, correct. Although this is really not easy to work with, right? But if I don't look at it for a moment, I realize that this is a proportion, right? 90 over blah, 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 50 over 1. Good. So what do we do? Right. 1 times 90 equals 50. Do not distribute. Just write it like this for now. Are we okay with this step? Yes? Are we okay?
So would you divide 50 down both?
I would divide exactly. I would divide both sides by 50. And I get 9 over 5 equals 1 plus 271 e to negative 0.122x. What am I really trying to do? I'm trying to clean it up. I'm far from applying log. Far. First, I have to notice that it's a proportion. Then, I have to divide both sides by 50. Now I have to clear the 1. Then I have to clear the 271. I only need this piece on one side. Everything else has to go. Otherwise, I can't apply log. Good. So now I have to move 1. But
that like 5 over 5.
Yes. If you want it like 5 over 5, it's fine too. So how much is 9 over 5 minus 5 over 5? It's 1. I'm moving 1 to the other side.
4/5.
4/5. One more step before I can apply log.
Divide 271.
Right. I'll multiply by 1 over 271. 4 divided by 5 times 271 equals e negative 0.122x. If you want to multiply by 5. If not, leave it alone. We're going to put everything in the calculator. Now it's completely cleaned up of everything. And now I can do what? And I have to. I have no choice. Now I apply natural log. Any questions? Any questions so far, please? So natural log of 4 over 5 times 271, don't forget it's a multiplication, equals, and the right-hand side is only, times natural log e. But how much is natural log e? 1. So then finally x equals natural log of 4 over 5 times 271. Now be very careful with that top. Let's put this in the calculator together.
Would you put the top part in the calculator, get the answer, and then divide that by?
You can if you want, but I recommend this. I don't like to do piece by piece, but that's fine. But you have to be very careful with parentheses. So the top is natural log 4 divided by 5 further divided by 271.
Can you put it all like that, or do we have to put 4/5 in parentheses?
If I put division, I don't need parentheses.
As long as it's all
If I put multiplication, then I need parentheses.
Okay.
So what I did was I divided 4 by 5 and then further divided by 271. Now, if you don't want to do this, that's fine, but then you have to put 4 left parenthesis 5 times 271, close the parenthesis, but then you have to close another parenthesis for the log. That's fine too. Divided by, don't forget parentheses, negative 0.122. So what I wanted to do is natural log of 4 divided by 5 and further divided by 271 to skip the so many parentheses, but it's the same thing. You're going to get the same answer. Negative 0.122. The answer is identical. So x equals 47.7. What does this mean?
47.7 years old.
Exactly. At the 47.7 age group, it appears that about what is the percentage of heart disease? 50%. So I'll let you solve the one with 70%. Do that for next time. I like to show an exponential decay.
Are we doing it right now? In each of it?
The exponential decay?
That is 7.
No, for next time. Do it for next time and tell me the answer. I'm trying to find something with the exponential decay. Yes, let's look at 87 on page 538. 538. 87 on 538. Use the exponential decay model. Here's the exponential decay model. Have we seen this one before? With one difference though. It's a negative in front of k. That's the only difference between exponential growth and exponential decay. But again, you don't have to memorize this. Okay, so let's read the problem. Use the exponential decay model to solve this exercise. The half-life, and I'll explain in a moment, of polonium-210 is 140 days. Take notes. Half-life, 140 days. What does that mean? Let's say we have in a sealed container 100 milligrams. We can touch that, it's radioactive. So what happens in 140 days? We're going to have only 50. What happens in another 40 days later? We're going to have 25. What happens? Exactly. What happens in another 140 days? 40 days. We're going to have 12.5. What happens in another 140 days? 12.5 divided by 2, and so on and so forth. Is that clear? Perfect. How long will it take for a sample of this substance to decay to 20% of its original amount? 20% of its original amount. How long will it take for any sample to decay to 20% of it? I have a sample, I don't even care how many milligrams I have. But I know that it decays to half in 140 days, and I would like to determine how long it takes for this to decay to 20% of it. Okay, yes, please.
So is K 100%?
No, we have to find K. This is our first step. We have to find K. So this means nothing just now. From the even information, from the fact that I know that the half-life is 140 days, I will be able to find K. And then I will be able to answer the question. Ready? So can anyone give us a point for the half-life? What point would that be? Let's think about it together. So in 140 days, the amount we start with will be how much? A0 over 2. This is the point for half-life. We are told, remember, T, A of T, right? T, A of T. Time is the independent and the amount is dependent. So when 140 days pass, then the amount we started with, which we don't even know what it is, we don't care. The original amount will be half of it, right? So this amount will be half of this, when t is 140 days. How do I plug this point in the equation? Tell me what to write on the left, tell me what to write on the right. What do I replace this by? Say it again. That's not the time. This is the amount. This is the mass. I cannot put the time here. This is the amount. What is it? Say it again. It's A0 over 2. We are not here. We cannot even think in these terms. We don't even know what that is yet. So it's A0 over 2 equals A0 e to negative k multiplied by exactly. That's why we established the point first so we don't make a mistake. Now, I want to clean it up. Can you please tell me what I should do first to clean this up? Exactly, because it's not 0 and I don't need it and I don't even have it. So I divide both sides by A0 or A naught. So this part is 0.5. This part is e to negative 140k. Indeed. I cannot divide just one side. All equations, when I divide, I have to divide both sides, whatever I'm dividing by. So the left-hand side is 0.5 times A0. I divide by A0, so I get 0.5. The right-hand side is A0 times E. I divide by A0, I only have E. It's completely cleaned up. Natural log indeed. So natural log of 0.5 equals negative 140k. And now k.
Is natural log 0.5 over negative 140.
Excellent. With a calculator. So we have natural log 0.5 divided by, in parentheses, negative 140. So 0.0050. K 0.0050. 4 decimal digits. So now we have the model. A of t equals A0 e to negative 0.005 t. Excellent. So now I'm ready to answer the question. How long it takes for the original amount to become 20% of it? I need the point. Give me a point. How long it takes, no clue, till the original amount becomes 20% of it. I have $100 in my pocket and you have 20% of what I have. How much do you have?
20% of 100.
0.2 times 100, right? So this is 0.2 times A0. 20% is remaining. 20% is remaining. So I need to put this point in the equation. Tell me how to put the point in the equation. What is this side?
It's the time, right?
No, this is the amount.
Amount.
Amount or mass. This is always the y variable. There is no discussion there, right? We always plugged in the y coordinate, right? 0.2 A0 equals A0 e to negative 0.005 t. And I'm after t, which I don't have.
Divided by A.
Bless you too, thank you. Yes, I have to divide. I have 0.2 equals e to negative 0.005 t. It's completely cleaned up. And now I apply log. So natural log 0.2 equals negative 0.005 t. Of course, t equals natural log 0.2, negative 0.005. Always think in terms of the point, and always remember the y is the y and the x is the x coordinate. Any questions? Okay, with a graphing calculator. So we have natural log 0.2 and divide by negative 0.005. So 321.9 watt. T equals 321.89 watt. What is T measured in this problem?
Days.
Thank you. Indeed. So it makes sense. From 100% to 50%, it takes how many days? From 100% to 50%. How many days?
140.
140. From 100% to 20%, how many days it takes? 321. It has to be more. Because now 80% disappeared. Very well done.